person. This is Tyler, that's Wesley, and we designed a hydro/wind-powered USB charger.
So the project definition is to design an object that takes renewable energy and uses custom power electronics to deliver power to two different unique loads, depending on what that is. So we decided to do hydro/wind power, so we're taking an AC 3-phase source and then converting that down to a 5-volt DC bus suitable for USB charging.
So our target market is anyone who enjoys the outdoors, especially people who go off to not well-populated, off-the-grid places that might still want some sort of electricity for their devices. Like your phone, it could help save your life if your phone dies. So that's our market. Especially somewhere near water or like on top of a mountain after a hike where it's windy.
So this is a general block diagram of our system. So we have our input, which is represented by this water wheel. It gets charged by this charge controller, and we have a battery here that stores all the energy that's being generated. And then we have our output on the right here. It gets converted down from a higher voltage 12 volts to 5 volts, which is our target output for most devices. And it's controlled by this Arduino.
And you can see here, we can either use the rectifier as the power or the battery. The battery will be charged by the 3-phase input rectified signal as well.
So just looking at the circuit itself, so you have your input there, and then your rectification here, just a simple 3-phase rectifier. Topology, your rocker switch, and then here's your gate driver circuit. This is simulating the Arduino's PWM output. The gate driver drives the P-channel MOSFET, which then drives the 12 to 5 volt buck converter.
So what sets our design apart from other similar products? We use a high capacity 12 volt battery, which we even had 2 that we put in. It can auto sense the output for consistent 5 volts. And then we use a feedback loop to reread the output to make sure that that's where the auto sensing comes in, to keep it a consistent 5 volts. And it has 2 USB ports for parallel charging.
Meeting the customer's needs. So it's, like I said earlier, it's a potential life-saving device that can be used to power your phone. So if you get lost and someone needs to ping your phone, they can. Also, the anxiety involved with having low battery when you're hiking isn't good, so having this device handy will allow the hiker to be free of that stress because their phone will be fully charged. And you can use your devices all day long, so if you want to have your map out to navigate, you can have that out at all times and go where you need to go.
So looking at the cost projections here, so we have the cost of the charge controller, the battery pack, the nano, the USB connectors, rocker switch, LEDs, voltage sensor, which comes out to about $54. So it's pretty inexpensive as far as power conversion goes. But I mean, those could be brought down with more efficient and probably in bulk parts.
And we could also sell this device for $100 even. That would give us a pretty decent profit margin if we were to sell this.
So some of the initial problems we had with the design came with our charge controller not turning on. We solved this by figuring out that it senses a battery at its output, so you have to have a battery in order to use it. Which we didn't know at first, and we wanted to run power through it, and either a battery's hooked up or just use it as 12 volts out. It didn't work like that. We had to change our design. Another difficulty we had was turning on our gate driver correctly, which was a P-channel MOSFET. We solved it by adding optocoupling, which just divides the high voltage and the low voltage circuit of the Arduino and 12 volts of the input. And then the last problem we had was making that optocoupler actually work correctly, and we solved that by changing some resistor values to allow for current to be in the spec of that device.
So conclusions and future improvements, adding in an additional source such as solar would be really cool because you could have more redundant, reliable charging, having another renewable thing added onto it. And then also adding on a boost converter so you can charge larger devices such as iPads or laptops, those higher voltage loads. And also improving the ringing at the output. So the output, we get a slight voltage ripple. This is due to a network in our inductor capacitor network. And we can improve this by changing the values of the capacitors or the inductors.
All right, thank you. Here she is.